Here's our review of Strand 1. So these are going to be in the first section of your SOL workbook. So on page 5 is where we have SOL 7.1a, which is all about powers of 10. And just as a reminder, this is a non-calculator unit. We had to investigate and describe the concept of negative exponents for powers of 10. So in this table, we've provided the decimal fraction and fraction equivalent form from the exponential form. So when you see 10 to the negative first, remember the way that we changed this into a decimal is that we started with a 1, and then since it was a -1 exponent, we moved our decimal one place to the left. And that got us our decimal form of 0.1. We can take an exponent form and turn it into a fraction by sending the negative exponent downstairs. Remember, we hold the story of if you have a bad attitude, your parents say, go upstairs, you have a negative attitude right now. You can't come back downstairs until your attitude is positive. So we can send that positive exponent downstairs, and that gets us 1 over 10, or 1 over 10 to the first. 10 to the first is just 10 by itself, which is why we can write it as 1 over 10. Now the fraction equivalent would just be 1 over 10 for this one. When we get to 10 to the -2, to change it into its decimal, we start with a 1. The decimal is always to the right. We move it 2 places to the left here because we have a -2 exponent. So when we move it twice to the right or to the left, the decimal is now here. That empty space is filled in with a 0. So that's how we get 0.01 or 1/100th. So this is rewritten as our negative exponent has to be upstairs. It's only allowed to come downstairs when it's positive. So 1 over 10 to the second, or 1 over 100, because 10 to the second is the same as 100. And this is written the same way as fractions being multiplied together. So 1/10 times 1/10 is the same as 1 over 100, which is why we are able to write it in this expanded fraction form, or 1 over 100 like this. So that's just a review of changing those from exponent to decimal to fraction equivalents. Just as a reminder, negative exponents are decimals and fractions. It does not make a number negative. So in some of those questions in your practice problems where it says circle all the true answers, if you see an answer that says 10 to the -1 should equal -10, we remember, no, negative exponents make decimals or fractions. It doesn't make negative numbers. So that's just what this is referring to. Now, this down here is just an explanation further of all of those spread out. So if you wanted to go through and kind of do some of those practice ones, you can, but this is just how we can rewrite all of these forms. Now our next section of Strand 1 is SOL 7.1b, and this is where we had to compare and order numbers that were greater than 0 written in scientific notation. And this is still a non-calculator topic. So in order to change a number from scientific notation or into scientific notation from standard form, if we take an example like 1,840, right now this number has a decimal all the way to the right. If you have $1,840, this is where we put the decimal to have our cents back behind here. So we need to place the decimal behind the first digit of the number. So the first digit of this number is a 1. So I want to move the decimal right behind it. And what I'm going to do is I need to count how many places I need to move my decimal. That's 1, 2, 3 places to move it back to where it started. This number is going to be the exponent in our power of 10. And now we have to think about, is this number a big number? Is it greater than 1? Or was it a small number? Was it less than 1? So 1,840 was a large number. So the number that I created that I moved my decimal for was 1.84, and we had to multiply this by 10 to some power. We get the power by counting our loops. We had to move it 3 times. And since 1,840 was a large number, greater than 1, we're using a positive exponent here. So now to change it back into that standard form from what we just had, if I write this as 1.84 times 10 to the third, to change it back into standard form, I just have to follow the rules of my exponents. So since I have a positive exponent here, I'm going to take the number 1.84 and I'm going to move the decimal 3 times to the right because I had a positive exponent. When I move it 3 times to the right, this is where it's going to end up. Any empty loops are filled in with zeros. So I get 1,840, and that's back with what I started with. So when you have a negative exponent, you're moving your decimal to the left, and that's for numbers that are less than 1. And that's what they'll be as in standard form, numbers less than 1. Oh, sorry. Pen's going crazy. So numbers less than 1 will be like this, and then numbers that are greater than 1 will have positive exponents. So we can do a negative exponent example. So if I have the number 0.021 is my number, and I need to write this in scientific notation. The first non-zero number here is 2. So that's where I'm going to end up moving my decimal. I'm going to have to do 2 loops here. So the number that I made is 2.1, and I'm multiplying that by a power of 10. I had 2 loops, so my exponent is a 2, but this number that we started with, 0.021, was a number that's less than 1. So that means I'm going to be using a negative exponent here. Now to go back and check to make sure that that works, I take 2.1, and I look at my exponent, it was a negative 2, which means I need to move my decimal 2 places to the left, and that gets me 0.021, which is what we started with. So you can always go back and check to make sure you did it right by trying out your scientific notation form into standard form again, and make sure you end up with what you started with. Now our next section of Strand 1 is SOL 7.1c, and it still is no calculator. This is comparing and ordering rational numbers. So remember, when you need to convert numbers to the same form, when you have numbers that you need to put in order from least to greatest or greatest to least, if you have a fraction and you have a decimal and a percent and you don't know which way to put them in order yet, just change them all into the same form. Now, it's usually easiest to change them all into decimals, but you can do what you like best. Some people like to put them all in percent, some people like to put them all in fractions, so whatever you prefer. So we'll do an example here, and we'll say, here's a list of numbers. We have 1/2, we can have 1/2, we can have 64%, we'll have 7/8, and maybe 0.52. And we're going to put these in ascending order. So ascending order just means that it's going up. So you can think of if you're ascending the stairs, you're going up the stairs, whereas descending order means you're going down. So if we have ascending order, we're going from the bottom to the top, so smallest to greatest. All of these numbers are in different forms. We have a fraction, we have a percent, another fraction, and another decimal. So we want to change these all into the same form. I'm going to put them all in decimal form. 1/2 is one of those fractions that you probably are just going to remember is always 0.5. 64%, if you have a percentage, to change a percent into a decimal, you figure out, okay, well 64 has a decimal right here. I need to move my decimal 2 places to the left to change it into decimal form. So that means that 64% is written as 0.64. My next number is 7/8, and we have 7 divided by 8. So we have to do some long division here if you don't remember what that fraction is. So we think to ourselves, okay, well 7 is being divided by 8. 8 can't go into 7. That's not possible. So what we have to do is add a decimal up top, which lets us add a 0 over here. 8 into 70 goes in 8 times. 8 times 8 is 64. We subtract, and our remainder here is 6. 8 can't go into 6, so we have to add another 0 and bring it down. 8 can go into 60 7 times. 8 times 7 is 56. We subtract again, and our remainder is 4. 8 can't go into 4, so we add another 0, bring it down. 8 can go into 40, and that's 5 times. 5 times 8 is 40. So when we subtract here, we get a remainder of 0, which means we're done. And our decimal form for 7/8 is 0.875. And finally, our last number in that list was 0.52. So now we're all in decimals, and what I like to do is stack them all next to on top of each other. So we had 0.5, 0.64, 0.875, and 0.52. To put these in order from least to greatest, we look in the ones place first. They're all 0, so they're all equal there. Then we look in our tens place. We have 0.5 and 0.52. So those both have the same tens place. Now we have to look in the hundredths. Remember, if there's nothing behind this 5, it's like having a 0 there. So that means our smallest number is going to be right here. So that's what we're going to start with, 0.5. Then our next smallest number will be 0.52 because we compare the rest of our tens place, 5 there, 0.52. So that was second. And then our third number is going to either be 0.64 or 0.875. Still looking in the tens place, 0.6 is smaller. So 0.64 will be our next number, which leaves our last number as right here, 0.875. The other way you can kind of think about this is once it's in decimal form, you can kind of treat it like money. So which one of these is the smallest amount of money? That'd be 50 cents, 52 cents, 64 cents, and then 0.875 cents would be more than the rest of those numbers. So this would be our final order for ascending order there. The next section is SOL 7.1D, which is determining the square roots of perfect squares. So it is important to try to memorize these, and that's going to give you that quick recall when you're taking your SOL. It is no calculator. So a way that you can try to remember if you don't have them memorized to try to figure out a problem on the test, well, if you see, let's try 5 squared. If you see this and you're like, I don't remember what 5 squared is, you remember an exponent just means you repeat multiplication. So we're repeating 5 times 5 just 2 times, and then you can remember, oh yeah, 5 times 5 is 25. Okay. Now for bigger numbers, it might not be as easy to remember that. So we have 14 squared, for example. You can still at least remember that 14 times 14 should get you what 14 squared is, but if you forget exactly what it is, do your multiplication however you would multiply two two-digit numbers together. So 4 times 4 is 16, 4 times 1 is 4, plus 1 is 5. Put your placeholder, 1 times 4 is 4, and 1 times 1 is 1. When we add all these together, we have 6, 9, 1, so that would mean 196 is what 14 squared is. That is our number there. And now going kind of backwards from that, when you see this symbol, it is called a radical, but we say it as the square root of 196. We can rewrite it as, well, we know that 196 is the same as 14 squared. And then we remember that square root and square are opposite operations. So that square and square root undo each other, which crosses that out, and the only thing you're left with is 14, which means the square root of 196 equals 14. So if you forget on the test, just do that longhand multiplication to figure out what the number is, and then the opposite of a square is a square root, and they undo each other. So once you figure out what number would go under there with its square, you can cancel out the square root and square to get your answer. The last topic in Strand 1 is 7.1e, which is identifying and describing the absolute value for rational numbers, and this is our final non-calculator section. And the absolute value of a number is just the distance a number is from 0. So if you have the absolute value of 3, you're going to have it with the 2 bars around it. It's not parentheses, it's the straight lines right around. And that's just said as the absolute value of 3. So it's how far 3 is from 0. So you would count 1, 2, 3 spaces, so its distance is 3. Down here we have the absolute value of negative 4. Negative 4, between that and 0, we would have 1, 2, 3, 4 spaces, so the absolute value of negative 4 is 4. So opposite numbers have the same absolute value but different signs. So negative 4 and 4 are opposites, and 10 and negative 10 are opposite. The opposite of 0 is still just 0. So that's just something to remember. Here's an example problem. We have find the absolute value of negative 5, and looks like that answer is actually wrong. So the absolute value of negative 5 would be 1, 2, 3, 4, 5 spaces away from 0. So the absolute value of negative 5 is 5, because the distance there is 5 spaces away.